Hi, good evening, everyone, and thank you so much for joining our session. As always, we would like to present to you this amazing series that we have been working on, where we are presenting the various different research papers that people have worked on. Okay. And we are trying to showcase their experience in that. So before we get into that, I have a very quick discussion I want to have with everyone who's joined today. The first is we have two people. We have Mr. and Mrs. A, and we have Mr. and Mrs. 360. Now, Mr. and Mrs. A, they've trained at XYZ Institute, and they've worked on various different dummy projects from places like Kaggle, GitHub, etc. Mr. and Mrs. 360, they've been trained at 360 Digit MG. They worked on real-time projects. They worked on daily stand-up calls. They worked on creating end-to-end data pipelines. Deployment being done on-premise and on cloud. Attended client calls, and they've had their research papers published in international journals. So, a very simple question here. Who do you think will get selected for the interviews? You can decide for yourself. So, without any further delays, I would like to present Madhu with us. Madhu, welcome.
Thank you, Aditya.
Yeah, so Madhu, why don't you walk us through the business details of your project?
It is one of the a client like a egg poultry industry. He will getting an issue with the counting of cracked eggs. It is a time consuming and laborious. So for him, we have done a project like a to make it as a like we by using a visualization or computer vision techniques, we developed a project. Based on the business problem, we have developed like a objective to minimize the counting of cracked eggs manually. And also based on that, for every project there should be a constraints. From that we build some constraints like cost, minimize the cost, and also minimize the consuming of egg crack detection, time consuming of egg crack detections, and also accuracy in prediction of cracked eggs compared to the human prediction. And this is about the project and business problems and all. When it comes to based on the project, we build like the success criteria. Like these success criteria will meet with the constraints or objectives. Business success criteria is at least we need to decrease the 10% of manual accounting effect. And the ML success criteria, at least 95% accuracy we will get the model, then only it will predict it will predict the accuracy greater than the human prediction. And economic success criteria, by developing the model, and the client will invest some amount, and based, and also he will inventory, he will give the labor cost for the human prediction. Based compared to the based on our prediction and all, we compare the cost, at least we need to save the money. So we build the economic success criteria, at least we need to $1 million of low compared to the human prediction cost. This is about the objectives on business problems.
Okay, perfect. So why don't you just quickly walk us through the project architecture and just explain all the steps that you have undertaken?
Like initially I comes to the collection of data. We have collected from data from the various sources like primary data and secondary data sets. When it comes to the secondary data sources, the client given 20 minutes of video, and also we have used some secondary like a it will be already available data sets we have used, we have tried. Based on that, from the client side we get 20 minutes video. That is not sufficient to build the model robustly. So we have make a decision to make the to build a prototype as exactly as like a real time. One of the issue is when we are getting the secondary data sources, here like the images should be black backgrounded. so that we can't getting the data exactly as like a uh, is in a like exact present in the client side. So we build the prototype exactly as like as, and we get the at least 2 hours of video, and we make it as a we stored in the Google Drive initially. After that, we all the data we have uploaded into the RoboFlow, and in the RoboFlow itself, we have all the like pre-processing techniques. It is a cloud. Sorry, initially we need to sell about. I need to tell about the RoboFlow. It is a cloud-based platform. We can done all the pre-processing steps to the image data sets. In that we are labeled, annotated, and augmentation techniques like flipping, rotation, scaling, transition, stressing all that, and normalization to the data set. These will use the more data when we are augmented. It will give it will based on augmented more data with the model will be applicable to more robustly. Based on that, we pre-processes, and one of the best by using RoboFlow is we can create data versions, so that we can apply when we try different like augmentation techniques, and we will try the model, and we will get it whether the higher accuracy or not. When we will get the low accuracy in the new version, we can apply to the previous version. This is the use of RoboFlow. And comes to the model building, we have tried out with the lineate RCNN, and the more like various techniques of YOLO versions like a YOLO V5, YOLO V8, and normal YOLO V9. The YOLO V9 is the new state of art the model in YOLO. Recently, like they are introduced like in February 22 or 23, maybe it is introduced. So that we can like the new model also we tried to give the best to the client. In the model building, we have some older CNN tech architectures. We have changed small techniques like by changing the hyperparameters like like dropout and the number of layers, number of connections in the, I mean number of neurons in the each layer. So we try different hyperparameters to get the higher accuracy with the like the old versions also. We get the different things, and based on the all the comparisons and accuracy, we get the highest accuracy of YOLO V9 with accuracy of 98%. This is the like model building. And after that, like we build after the model, we have deployed this model in the Streamlit using to like to see the client what is going on, how it is the model we are predicting, where it is predicting correctly or not. We have developed a web-based model deployment. This is about like the about the project briefly.
All right. So just for reference, these are the different accuracies that Madhu was talking about for the different models that were tried. So Madhu, can you just quickly, in like 30 seconds, explain what we see in terms of the output here?
We have like in the client side, there is two types of like eggs. One is white eggs, and another one is brown. In that, there is a in brown there is a cracked and intact eggs, and also in white also there is a brown and cracked and intact eggs. We are just predicting like a brown cracked eggs. Like when we see this is the model is predicting, it will show when it is a cracked and brown. When it is a cracked and it is a color of brown, it will show you brown cracked egg with the confidence of the machine saying I have confidence of this much. The model is predicting 1. I means the confidence level between the 0 to 1. The model is saying the confidence of 1. You can I can say like it is a cracked and brown. And here also you can see it is a white egg. So it is showing 0.5 only confidence. I can assume 0.5 only. It is a brown cracked egg. It is the wrong prediction. It is made the model. So it is model is the model is saying 0.5 only. This is a brief about output. So
Thank you so much, Madhu. So this is your certificate for a job well done. And we are definitely all very proud of you for the work that you have done. And congratulations on this major achievement. So,
Thank you, Aditya.
so before we sign off, I would like to discuss a little bit about the various things that we as a EdTech organization offer. We offer challenging real-time projects that are going to push you to your limits. We offer you the opportunity to learn about all the different phases of the project methodology. You can learn about the different tools which are used in the industry like Python, Power BI, etc. You can work on research papers which are published in international journals. And you'll have access to various free tools like the mind map, ML architecture assistant, resume mapper, and animated learning. So thank you, Madhu, so much for joining us, and thank you for taking the time to share your experience. And we would like everyone to follow our Instagram, YouTube, and LinkedIn channel so that you can get more of the same content. So, from everyone here at 360 JMZ, good evening and thank you.
Thank you, Aditya.